in terms of, let's fill F in after we deal with these two columns, okay? So first, just go down the line and fill in the either zeros or undefineds that you know of. So we know that at pi over 6, my second derivative was 0. At pi over 2, my first derivative was 0, and that was all. And then at 5 pi over 6, the second derivative was 0. At 5 pi over 4, both of them were 0. At 3 pi over 2, the first derivative was 0. And at 7 pi over 4, both of them were 0. Because we found all of the places where the first derivative is 0 or undefined, if the first derivative is positive for a certain value, it's going to be positive for every value on this side of the 0. If it's negative, it's going to be negative for every value on this side of the 0. So I just need to test one value that falls between 0 and pi over 6 to see whether or not the first derivative is is negative or positive, and then I can fill this whole thing in with that same sign. So I could just pick pi over 6, for example. I plug it into my first derivative. Cosine at pi over 6 is positive. I only care if it's positive or negative. I don't really care what the value is. So cosine at pi over 6, because I'm in quadrant 1, cosine is positive. Sine is also positive, because I'm in quadrant 1. Add 1 to that, it's still positive. So I have positive times negative, so what's the sign going to be?
Negative.
Negative. So I can put negative, negative, negative. Probably it's going to change signs on the other side of that 0, but not necessarily. So, kind of don't be surprised if it changes signs, but don't just automatically assume it either. So I'm going to test the 5 pi over 6. Now 5 pi over 6 is over here in quadrant 2. We've got to be a little careful because it's still easy enough to kind of do what I did before. Cosine is negative in quadrant 2. Okay, so this is negative, so negative times negative is positive. Sine is positive in quadrant 2. So positive plus 1 will be positive. So I will have positive times negative will be positive. So it does change signs. And then on the other side of my chart. Okay, so continuing down the F prime line, now I want to pick something that's between 5 pi over 4 and 3 pi over 2. 4 pi over 3 would be in between those two.
Yeah.
Okay, so 4 pi over 3 would be in between those two. So I'm testing 4 pi over 3. Okay, so in quadrant 3, cosine is equal to a negative number. It's negative half, actually. So they're both negative, yeah. But what's true about sine and cosine, neither one ever gets bigger than 1. Okay, so at 4 pi over 3, sine is negative. but when I add 1, that'll be positive. So this will be positive, this is negative, so the overall sign is still positive. Yeah, and that's, exactly, that's what happens. Okay, so 3 pi over 2 to 7 pi over 4, 5 pi over 3 falls in there, right?
Yeah.
So test 5 pi over 3. So in quadrant 4, 5 pi over 3, cosine is positive now. So I have negative times positive. This is negative, but it's less than 1. So that negative number less than 1 added to 1, this whole sum is going to be positive. So negative times positive times positive. Negative. And then between 7 pi over 4 and 2 pi, 11 pi over 6 would be something to plug in or think about. I mean, honestly, I'm not even really plugging the number in. I'm just kind of thinking about where I am in the quadrant. All right, so
Cosine's positive.
cosine's positive, sine is negative, but this sum will still be,
So you're still negative.
I still have a negative.
What were you selling?
Pardon me?
I understood that for the most part, but why is that one under less than 1 there?
Well, sine at 11 pi over 6 is negative a half, but negative a half plus 1 will be positive. Will be positive.
Slide lapses.
Okay, so this tells me that I'm going downhill, I'm decreasing, but then I change and I'm increasing, I'm increasing, but now I'm decreasing. Okay, so that's what we're going to fill in the F part. And by the way, if you're filling in a chart like this on your test next week, you can write arrows instead of writing out the word increasing or decreasing if you want. I didn't do that initially with you guys because I wanted to make sure you were hearing the word increasing or decreasing. Okay, so we're going to do the same activity with F double prime. So pick some value that is between 0 and pi over 6. Again, we honestly don't really have to pick an exact value. You can just, because of the sine and cosine, I think it's easy to just sort of think about where you are in the quadrants.
Yeah.
If it were a polynomial, you may want to go ahead and plug things in. It kind of just depends on how complicated. But basically, you're plugging a number in, and because we found all of the zeros or all of the places it's undefined, it's not going to change signs unless you pass a 0. So once you find one value, you can just kind of stick with it. So in quadrant 1, here's my second derivative. You know, with this one, I guess we are going to have to be a little bit careful because by the time you square a number that's less than 1, it could change it. So we're probably better off kind of plugging this stuff in. So why don't, I can pick 0. I mean, 0 is one of the values.
Yeah.
So if I plug 0 in, it's negative because sine of 0 is 0.
And 4 times 0 is 0.
And 2 times 0 is 0.
So you get negative 2.
Okay, but now between pi over 6 and pi over 2, so like pi over 3 would be an example. Okay, so I'm going to test pi over 3 for here. But I might want to plug it in. You can, I'm going to try to do it without the calculator, but you could do it on the calculator too. So sine of pi over 3 is being squared, and then we are adding to...
Yeah, adding 2 sin x.
Okay, 2 sine pi over 3, and then subtracting 2.
Yep.
Okay, so I get 4 times the square root of 3 over 2 being squared, and 2 times the square root of 3 over 2 minus 2. So 4 times 3 over 4 is positive.
Yeah.
Okay, so we get positive, and that's gonna be positive all the way down here, yeah, so positive, positive. And then between 5 pi over 6 and 5 pi over 4, so pi would be a good thing to plug in.
Be even.
Yeah.
Easy one.
So again, 0, 0,
Negative.
negative. So it's negative. And then between 5 pi over 4 and 3 pi over 2, again, we could test 4 pi over 3. So at 4 pi over 3, this is negative.
So it's a lot of negatives.
Yeah, so we get 3 minus square root of 3 minus 2. This is 1 point something, so this is going to be negative.
Yeah.
The square root of 3 is 1.7 something, so 1.7 minus 2 is more than 3. So it's negative. And then it's negative all the way through here, negative, negative.
So then you can use 11 pi over 6.
11 pi over 6, yes. So 11 pi over 6. If we use 11 pi over 6, then
Something.
I would get 4 times a half squared plus 2 times a half. This is a fourth. So 1 plus 1 minus 2 equals 0. Wait a minute.
Hold on.
How come we're getting 0? Maybe I left out one of our... What was our, I'm trying to remember what our factors were, because I didn't break the factored out for them.
It was 2 times, was it negative 2 times?
Because we have sine equals a half and sine equals negative 1.
Yeah.
Right.
Okay, so sine equals a half, but sine's a negative a half there. Oh, that's right, this is negative, that's negative.
Okay.
So that would make that negative 1, so this makes this 1 minus 2, which is negative.
Gotcha.
Okay, so negative,
So it doesn't change signs.
I'm surprised it doesn't, hang on, let's just start from scratch, okay. 4 times sine of 11 pi over 6, and that's being squared. And then we're adding 2 times sine of 11 pi over 6, and then we're subtracting. So 11 pi over 6 is negative 1/2
Squared.
over squaring. And then negative 1/2. So 4 times a fourth minus 1 minus 2. I'm surprised it doesn't change sign there. I'm trying to think why it would not change sign. I guess it could just be flat enough that it doesn't. Well, let's go with it right now. That's right at the end, so if it needs some slighted, I can't imagine what we're adjusting though, so 7 pi. Because we also could plug in 2 pi. If you plug in 2 pi, you're gonna get negative 2. Okay, so from that information, I know the graph is concave down, and then the graph turns to concave up. So I must have an inflection point at pi over 6. And then the graph stays concave up and stays concave up. If I change from going downhill to going uphill and my graph is concave up, those are 2 clues that I have a minimum. Okay, if I was going down and then I started to go up, I must have hit a minimum. Or if you draw that, you'll also see you have concave up. All right, then it changes to concave down, so I must have another inflection point. so, let's see what's going on here. It's concave down, but the second derivative is 0. I mean, before this is concave down, it stays concave down. I was increasing, I'm still increasing, so I must have, it must just hit a plateau. Okay, I must hit a plateau point at that point, and it's probably a maximum. It is a maximum because of the concave down. So I sort of hit a plateau, but it's also a maximum. I mean, when we draw it, I'll point out why I'm saying it like that. Okay, then it's concave down still, because it's concave down, and this is 0, I must have a maximum. And then we are still concave down. Something seems goofy. Why it stays concave down that whole time? Let's double check the between 5 pi over 6 and 5 pi over 4. So we plugged pi in, right? And that gave us negative, yeah.
0, 0 minus 2.
Yeah. Okay. So something seems weird though.
Mine are 3 maximum.
I know. That's why something seems weird.
Time to throw it for that.